Hello everyone and welcome back to our series going through the Pearson IGCSE Spec. I am Chemistry with Kenny and today we are going to be looking at forces and momentum. So we're going to be combining a few equations together. This is really good for you high level students out there, and this is a separate science or triple science, whichever language terminology you use. So if anybody on combined science, you don't necessarily need this, but this skill is really important moving through to A-levels. If you are thinking about A-level sciences, especially A-level physics, combining equations, super important. Now there's a couple of videos that I'm hoping you have watched on this series. The first one being Newton's second law. So if you haven't watched that, the link should be up in the top right now for you to have a click of, and you can watch it. So Newton's second law, that equation is force equals mass times acceleration. F equals ma. Super famous equation. You might have looked at that even before you started GCSE. I do that sometimes with my year 8s, that equation. Now the next one is acceleration. Okay, once again, video should be in the top right for you to click if you haven't watched that already. And this one is A equals V minus U divided by T. And if we just talk about what those mean, A is obviously acceleration. I think that one we should be fine with. This V here is your final velocity. So the velocity at the end. And this U here is our start velocity. You'll also hear that called initial velocity. Then T is time. I don't feel like I need to label that one. You should be fine with that one. Then finally, the last equation we're going to link in here is momentum, and this is on the last video that I actually uploaded about calculating momentum, so that will also be in the top right. And this one, momentum, given the symbol P, equals mv, mass times velocity. Now what we're going to do is start combining those together, and this is a really valuable skill. I know I've already said that, but it's a super valuable skill, being able to combine equations. So we're going to start with F equals mass. And now instead of writing acceleration, over on the left, I can see what that A equals. That A equals V minus U divided by T. So now instead of writing A, I can add in that equation. So I've substituted in that equation. Now from there, I can now expand that out and I end up with F equals M times V minus M times U all over T. Okay. And now we already know that V means final velocity, that U means start velocity. And I can link that with our momentum equation, which is mass times velocity. And I can end up with the equation F equals final momentum minus start momentum, running out of space, all over time. Okay. Now you'll also see this written as, let me just come up here, F equals mv minus mu over t, like we've got there, but F equals delta mv, or actually sometimes you'll see it written as delta p over t. Okay, that delta meaning change, and we know momentum is p. Okay, so you'll see it written as both of those. Super important. Now we can come down here, and this is where it applies. Whenever we talk about collisions, this is when we really want to focus on this equation. Now in your exam, anytime you see the word collisions, you need to think about this equation. I'm going to write it again because I've moved down my screen just so we can see it here. So F equals mv minus mu over t. Now, the reason we need to focus on it is during a collision, we want to increase time because, and some of you will already be able to figure this out, if we make time bigger, because it's dividing, that makes the force smaller, because this reduces the force applied. Okay, so increase the time, reduces the force. Okay, let's change the color of that so it stands out. Let's go with red. Well, I managed to get that G as well. So really important point to constantly think about whenever you see this word collisions in an exam, two things hitting each other, we think about this equation and we think about how is that thing that they're talking about changing the time. That's normally what they're getting at. So it might be the my year 8s, if any of you are watching this, and sorry, it was my year 9, sorry, if any of you are watching this, you'll know the question I'm on about when I say the tennis player's shoe. So how does the thickness of a tennis player's shoe change the force they feel and stop them from getting injured? But there's three really common things here when we talk about cars. The first one that we could think about is a crumple zone. Crumple zone, okay? And what this does is the front of the car, that's how you spell car, front of the car is designed to squish. You can kind of see it here. So the front of the car, instead of being a nice rectangle, ends up kind of squashing in, a bit like a cartoon. And that is all designed to increase the time it takes for that car to slow down. I'm a big F1 fan, and in F1, whenever there's a crash, it looks horrible because there's bits of the car everywhere. But it's because those bits of the car are designed to crumple, to break, takes away some of that force that driver feels. So ends up saving lives. Number 2 is a seatbelt. Okay. Now seatbelts actually do something slightly different. They're not really focusing on slowing down the time. They are basically keeping you attached to the car. Now the reason the seatbelt is there is when you have momentum, when you're driving a car or someone's driving a car, the car has momentum, you have momentum, everything that is not connected to the car inside that vehicle also has momentum. So you might have seen this before, you're driving along or someone's driving along, they hit the brake really hard, you move forward a little bit, but the seatbelt keeps you there, but your bag that's on the seat next to you goes flying into the seat in front and stuff goes everywhere and it's a mess. Okay, that's all because of the seatbelt is keeping you attached. If that seatbelt wasn't there, you would also go flying forward, which means you might end up hitting something and getting hurt. And if you do go flying forward, hopefully the third thing, the airbag, is there to catch you. Now airbags are basically giant cushions. Okay, they inflate really quickly. Okay, and as you hit them, so they inflate quickly, deflate slowly. So as you hit them, they start to depress, release the gas out of them, and they slowly deflate, making that time as big as possible. Okay, really important features. These are all obviously very specific to a car, but you could apply these to anything. They put airbags on, sometimes they put them on robots that they send to different planets. So as they land, these airbags inflate, hits the surface of Mars, let's say, the Mars rover, hits the surface of Mars and deflates, protects the sensitive machinery inside. Okay, so that's collisions, and that's 3 features of a car that will help protect somebody if there was a crash. Now, coming down here, we have an exam question. Now, this is from a real exam paper, so I want you to have a go at these questions. So there's part 1, part 2, part 3. It's all using those equations, or that main equation we spoke about up the front. Okay, so take your time, write out the equation, write out the variables, substitute, get your answer. Be careful of units. Be really, really careful and mindful of units. That's the one little trick that the examiner can play if they really want, is messing with those units. So just double check. Once you've done that, on the page below, there is lots and lots of questions. So I've got one as an example here that I've answered. So I've got the equation that we're using. From the question, I've pulled out all the information. And here we're trying to find our final velocity. I throw in all our numbers. So here, just below where I scribbled out, it says 20 times 0. So that gets rid. We end up with 20v divided by 7. Move it around a little bit, and we can end up with our answer. You can put your answer right there. Okay. Then there's a couple more exam questions at the bottom. Now look, 3 marks, 4 marks, 3 marks. It's a lot of marks for these sorts of questions. We're picking up a huge amount during these exams. Anyway, I've been Kenny. Please check out the rest of the series. Don't forget to subscribe, and also check out the link below where you can download all of my worksheets completely free. Thank you.